Hi, this is Suchi, and in our previous videos, we were talking about loops. Today, I will show you we can use else statement with loop. How we can do that and what does that mean? I think in Python, you might have observed that we can add else statement along with a loop. That might be a while loop or might be a for loop. So let's look into else with a loop. So let's look into the for loop with else statement first. So let us take one scenario. Prime number check. So we might have some number here and we have to check whether this is a prime number or not. So how we can do that? Prime number is a number that cannot be divided by any other number apart from 1 and the same and the number itself. So that is called a prime number. Now, as you know, 17 is a prime number because we cannot divide 17 with any other number apart from 1 and 17 itself. Whatever code we are going to write, this should check whether the number is prime or not prime. Now, what is for else loop? Let us look into the syntax first. So what we can do is for, let's say for I in range, something, let's say 5. And if we add some if statement here, if I is 7, then print breaking the loop and we will add a break statement. So if I is 7, we will break the loop. Otherwise, what we will do is we will print normal. Okay, we will print the value of I So this is a normal loop. As you can see, this I is not, this range is 5. So it will be running from 0 to 4 and I is never 7. So it is not breaking the loop from anywhere. So this statement is not executed as well as the break statement is not executed. It has only executed this value of I equal I. So let me just have this before this statement. So here you can see this is the normal execution of this loop. Now let's say I'm having 15 over here. So what will happen? Let us run this. Okay, so if I run this, what you can see is the loop is running for 0 to 7. But once it reaches 7, it enters this part. And when it enters this part, what happens is it executes this and then it breaks the loop. So the other executions are not happening. So from 8 to 15, 8 to 14, it is not happening at all. So this is called breaking the loop in between with a if statement. If I remove this if statement, if I comment out this if statement, you can see this loop is running up to 14, 0 to 14. So this is the normal execution of the loop. But when it encounters some if statement, which also includes a break in it, it will not be executed normally. It will break the loop in between. So if I remove this break statement also, you can see we are having this 0 to 7 and then we are having this print statement executed. So you can see breaking the loop, but it is not breaking because we have commented out the break statement and here the rest of the loop is also executed. So in this case, this is also a normal execution of the loop. But when the loop is executing a break statement in between and it does not complete the entire iteration, it will say that this is not a normal execution of the loop. It has been broken in between. So in this scenario, when we have a break statement, we can see the effect of a for else. So if we add a else statement here, we can say, sorry, loop has not been broken in between. So now you can see what will happen is, if this loop is broken in between, then the else part will not be executed. But if we have a normal execution of the entire loop, so the loop has been executed correctly, normally, so it will now come to the else part. So you can see that if this, else this is working. So if any if statement is having a break in it, inside it, then what will happen? The loop will not have a normal life. So when the loop is not having a normal life, the else statement will not get executed. This will only get executed when the loop is having a normal life. And this clearly means that this if was never satisfied. That is why it was never broken inside. It was never broken in between. And hence it is coming to the else part. So we can consider it like this. If this if statement is never executed, if this if condition is never satisfied, then only it will come to the else part. Otherwise, it will not come to the else part. So even if a single time is this if statement is satisfied, it will not come to the else part. Let me add a 8 over here, so it will run till 7. So here you can see, even though it is only running till 7, even though the loop loop is seemingly executed, completed its full life, but it is coming out, the control is coming out from this break statement, because this if statement, this if condition is satisfied at the end when we encountered this 7 value of I, and then it is also executing this statement. So if this is executing this statement, and if it is going to break, and from the break statement it is coming out of this loop, that is why the else part is not being executed. So what you can see here is, if by any chance this if statement is being satisfied, this if condition is being satisfied, and the if statements are being executed, and if there is one break statement inside that, and the control is coming out of this loop with the break statement, it will not enter into this else part. But in case this if statement is never satisfied and the control is not going to this break statement, it will always execute this else part. So either this one or this one will be printed. Now, how we can use this logic in our use case? So as you know, prime number, we have to check for the very basic logic without implementing any optimization. What we can see, we can divide this 17, we can divide this number with starting from 2 to n minus 1, and we can check if by any number it is being divided, then it is not a prime number. But if it is not being divided by any number starting from 2 to n minus 1, it is a prime number. So let us implement that logic first. So what we can do is, we can run a loop for I in range. We will start it from 2 and we will stop before the number. So this will be for I in range 2 to n minus 1. We'll stop before n. So what we can do first, we can print I here. So as you can see, I we are printing here. Now what we can check is, if this number is divided by this number or not, divided by I or not. So we will check n is divisible by I or not. And also let us print what is the value after remainder division. So if we see, let us just print it here. N remainder division by I equal this one. So as you can see, if we divide 17 by 2, then 1 is the remainder. And if we divide 17 with 3, then 2 is the remainder, and so on. So we can see all the remainders are present here. So how we will see, how we can say that this number, this n is divisible by I or not. If this remainder is 0, then only it is divisible. So what we can check, we can add a if condition checking that if in remainder division I is equal 0, then print not prime, because if it is 0, then it is divisible. So n is divisible by some number means it is not a prime number. And we can also break it from here. So let us have this. Let us have this. And if we add the else statement here saying that it is a prime, then what will happen? It will unnecessarily print everywhere that it is a prime number whenever it is having some remainder. So let us run this to see what is actually happening. So here you can see it is every time it is checking if it is getting any remainder, it is saying it is a prime number. So if I am sending, let's say for 9, for example, here you can see, here it is saying prime, but here it is saying not prime. When it is being divisible by 3, it is saying not prime, but again it is continuing the rest of the part. But here itself we got to know that it is not a prime number. So we can do what? We can actually break from here. Okay, so we can actually break from here. So here you can see this is saying prime once and then it is saying not prime. And then it is breaking out of this loop. It is not checking further. So if it is 17, what it will do? It will print prime that many times. So this is a problem basically. How we can overcome that? Now you can say that, okay, if this loop is being executed and if it is never broken from here, we can come to the conclusion that it is a prime number. So this else part, then we will move to the level of this loop. So if this entire loop is executed without breaking anywhere, without breaking it from anywhere, then only we can come to the else part that, okay, if it is not divisible by anything, then it is a prime number. So if we run this now, you can see this loop is entirely executed. It is never printing not prime or prime inside this loop. After everything is done, it is saying it's a prime number. So let me just remove this print statement so that it is more visible. So here you can see 17, it is printing as prime number because it is never divisible. It was not divisible by anything starting from 2 to 16. Now, if we check for something else, let's say 25, here you can see it's a not prime. Why it's not prime? Let us uncomment this line and let us see. Okay, so 25 divided remainder division by 2 is 1. This is also 1, 1. And now when it is being divided by 5, you can see the remainder is 0. So it is divisible by 5. So it is saying it's a not prime. But when it is saying it's not a prime number, it is never saying that it is a prime again. So the logic is working perfectly. So we can simply comment out this part, or we can remove this line, and you can see our program, our code is running correctly. The same thing we can also do with a while loop. How? The same logic. Just let us copy this. As you know, we can easily convert a for loop into a while loop. We can have I initiated with 2, initialized with 2. And here we can remove it. We can change it to while I is less than n. Then do these things and increment I with 1 after every iteration of this loop. Now this will be doing the same thing. So here you can see not prime, not prime. If we add something like, let's say 13, it's a prime number. It's a prime number. So here you can see this is working fine. So this is how we can add a else statement with a loop. So that's it for today. Thanks for watching and keep learning, keep implementing.